Remember when the boom was at a 60-degree angle and we were trying to find the distance from the line of force to the pivot point? And I told you that in a 30, 60, 90 triangle like this, the short side is always half the hypotenuse of the long side. So, and another way of saying that is take the hypotenuse, the long side, multiply by 0.5 to get the distance, 18 inches. When the boom is at 45 degrees, we multiply by a different number, 0.707, to get the distance. Same thing with 30 degrees. Now that special number, all these numbers here, is actually called cosine. Now don't run away, trigonometry is not that hard. Triangles have three sides, so there's only so many ways you can juggle them. With cosine, it's the ratio of the adjacent side to the hypotenuse. Adjacent side to the hypotenuse, the cosine of 60 degrees is 0.5. The cosine of 45 degrees is 0.707. Now the problem we have is we don't know the angle, but we do know the distance, because the distance from the truck to the crane is 34 inches. And the boom the hypotenuse is 36 inches. So the ratio is 0.944. So what do we do with that number? Well, we take you need your handy dandy table of cosines. I try to suggest to my students not to use their calculators, but to print out the table of cosines. So they can see that as the angle changes, the angle gets smaller, the cosine gets bigger. 60 degrees, the cosine is 0.5. Go down to 30 degrees, the cosine is 0.866. You can see that here. The hypotenuse stays the same. It's always 36 inches. But the distance gets larger, from 18 inches to 34 inches. So the cosine of the angle theta, we don't know what it is 0.944. What do? Look up in the table of cosines, the closest we can get is 0.945, which is 19 degrees. So that's our answer. If we put the boom down to 19 degrees, hold on a second. That'll give us the 34 inches we need. Now I'm putting it at 20 degrees, and you'll see why in a minute. When we start to lift up the load, watch what happens to the boom. See, it gets pulled down. That's why I started out at 20 degrees, and we're going to end up at 19, which is where we want to be. Now back to the problem we have. You're going to have to figure out this stuff. The torque of the load we figured out before, weight times distance, right? 2 bricks is the load, we know the distance is 34 inches, that's what you get. Now what about the torque of the boom? Boom weighs 5 pounds. How do we figure out the distance? Well, theta is 19 degrees, and the cosine, the number, is 0.944. So we took 36 times 9.44, and we got 34 inches. Now, the CG of the boom is about there, so this distance, instead of 36 inches, is 20 inches. So 20 times 0.944 is going to give you 18.8. So that's the distance. 18.8 times 5 gives you, you're going to have to figure that out. I'll give you some rough numbers, but take out a paper and pencil and you figure it out. I'll have the answers for you in the next video. Let's say it's 80 something. let's say the total, the combined torque is 400. Don't forget the safety factor. If it's 400 inch-pounds on this side of the pivot point, this side has to be 1.5 times greater to prevent it from tipping over. So 400 times 1.5 is 600. So we need 600 on this side of the equation. The crane side, we need 600 inch-pounds, roughly. How much do we have? We've only got 140. That's a difference of 460 inch-pounds, not 460 pounds. That wouldn't make sense. Inch-pounds. So we need to get 460 inch-pounds. It's weight times distance, right? We don't know the weight, but we do know the distance, because it would make sense to put the counterweight the farthest point away from the pivot point, which would be right here, all the way at the end. That's 24 inches from the pivot to where the counterweight is. So, if the distance is 24 inches, 24 times whatever the weight is going to give us 600 or so inch-pounds. You figure that out. I'll have the answer for you in the next video, but I'll give you a hint. The amount of counterweight we're going to need: 3 bricks, plus a piece of steel that's over 8 pounds, and the boom's at 19 degrees. Let's see if it's going to work. Pretty stable. So the next video I'll have the answers to this, and then I'll tell you about sine, a different part of trigonometry, just as easy as the cosine.